Okay, so I've had a few questions in regards to the water quality assignment that I've given you. I realized that the very first virtual learning tool cannot be done. You can choose to delete it or just leave it empty. It doesn't matter to me. We did go over one of the virtual learning tools in class, the very last one. And I know one class we wasn't able to do this completely. So I thought I would go ahead and be a little bit more definitive for my second class. And for those of you that wasn't able to understand it or complete it in the first class, you'll have access to the screencast as well. Um, so essentially, using bioindicators to determine water quality is measuring the biodiversity that should be there in that water system. So let me just back up a minute and let you know what biodiversity is. Biodiversity is the degree of variation in an ecosystem or in a species even. So in other words, we're talking about the many different types of organisms there are in an ecosystem, or the many types of different characteristics that you find within a species. So, for example, there are so many different types of caterpillars. There are so many different types of insects. The human, the human species is very diverse in that we can be separated by outward appearances such as height, weight, color of eyes. So, the human species itself is very diverse. So examples of ecosystems that are very diverse is the Great Barrier Reef. It has a lot of different types of reptiles, a lot of different types of fish, coral populations. So it is very diverse. Another one would be the tropical rainforest. It's arguably probably the most diverse ecosystem. So it has different types of insects, different types of mammals, different types of amphibians living there. Very diverse. And then finally, we have the Appalachian Mountains. We have thousands of different plant species, thousands of different insect species, many fish species. So one of the ways that we can calculate and determine the quality of water is by knowing what should be in the water and comparing that to what actually is in the water. So the whole purpose of using this virtual learning tool is to get an idea of the many different types of organisms are found in a water system, um, and then multiplying it, giving that a number based on how well that organism survives in polluted water. So let's get started. I'm not going to go through and tell you each of the answers, but I am going to give you an idea of where to find some of these answers. So the very first one discusses what macroinvertebrates are and where they're found. You can find that up here in this little bit of information. And then it wants you to categorize each of the different groups of macroinvertebrates based on their tolerance in polluted water. So it starts with group one. These are organisms that are intolerant. They don't survive in polluted water ever. And then they have group two that are moderately tolerant. So they can tolerate some pollution levels, but would prefer for the water to be clean. And then you have organisms. This is bioassessment group two. And then you have organisms that thrive in polluted water. In a lot of cases, you'll find these in lakes and ponds full of dendritic material where there are some other living organisms, but these organisms actually break down a lot of the pollution that's in the water. And that's our bioassessment group 3. All right, and then it gives you the 4 steps that scientists use to determine water quality. I realize that's a question on your document, so make sure that you're putting that into your own words. And then they give us an example of how that they would measure water quality. And again, they're measuring the different types of organisms that are found, not the number of organisms that are found. So you could see here where that they have found 3 different types of intolerant organisms. If you add this number up, that's 5 organisms that they found. Of those 5 organisms, there are 3 types of intolerant and then you move down, and they have the different number of organisms they found, and then they have 4 different types of tolerant organisms, moderately tolerant, and so on and so forth. Okay, so because this is to determine the amount of pollution that's in the water, then we're going to multiply each of these numbers, giving it a higher number whenever there are more intolerant organisms found. So we multiply the intolerant organisms by 3, the moderately tolerant organisms by 2, and then the tolerant organisms by 1. Because they are there, they are present, they do need to be recognized. And then we'd add all of those numbers up together to get our total, and we use the water quality index to determine whether or not if that water quality condition is an excellent condition, good condition, fair, or poor condition. And then it gives you the opportunity to do it yourself. Not everyone's answers will be the same, because every time that this is refreshed, then you get a different set of organisms. All right, so it's good to note that they're giving you the 3 different types of groups, but they're not separating them for you. You have to separate them yourself. So they want to know how many different types are from group 1. So a damselfly, that's group 2, does not count. Water pennies, it says water penny larvae, so we'll count that as 1. Snails that are not pouched, that's in group 1, so we're going to say that's 2. Dragonfly larvae, that's in group 2, does not count. Clams is in group 2, does not count. Caddisfly larvae, that's in group 1, that does count, so that's 3 we found. Stonefly nymph, that's in group 1, so that counts, that's 4. Cranefly larvae, that's in group 2, does not count. Mayfly larvae, that's in group 1, it does count. So we found 5 different types, so we put 5 in and we check it, and it says we were right. And now we're going to count how many different types from group 2. So we have found the damselfly larvae, that's in group 2. That's from group 1. Group 1, dragonfly larvae, that's in group 2, so that's 2. Clams is in group 2, so that's 3. Caddisfly larvae is none, that's from group 1. Stonefly is from group 1. Cranefly larvae, that's in group 2, so that's 4. And mayfly was from group 1, so we'll put 4 here. And then if we go back through our list again, we did not find any of the organisms found in group 3, so that's 0. So now we're going to multiply each of those numbers based on the number of points that's awarded for each group. So we had 5, and we multiplied that by 3 to get 15. Number 2, we multiplied that by 2, and we found 4, so that is 8. And we didn't have any for 0, so we combined these two to get 23. Cumulative index value is 23, and so that tells us then that our water quality for that stream was in excellent condition. So I hope this was helpful in determining the water quality for the virtual learning tool that I had given you. Please email me for any further questions.